Welcome, everyone. I'm Santosh Raikar, and today we're going to talk about a phenomenon every plant manager fears but many inadvertently design: the 2 a.m. failure. We are going to look beyond the immediate technical fault to explore how shift handovers, human fatigue, and the lack of 24/7 reliability systems create the perfect storm in our industrial environments. Imagine it's 2:13 in the morning. A pump vibration alarm is acknowledged but not investigated. A temporary hose is in use but not logged. The standby pump status is a mystery because the team is exhausted after a long storm response. The failure risk here isn't just a mechanical part. It's a breakdown in state transfer and fatigue management. Ask yourself, what should this team know and decide right now, rather than waiting for the morning? Why does this matter so much? Because physics doesn't change at night, but our support systems often do. Reliable plants don't just hope for the best, they engineer continuity. This means treating handover as a critical safety barrier, managing fatigue as a predictable operational risk, and ensuring night crews have the same decision-making power and technical support as the day shift. By the end of this session, you'll be equipped to treat fatigue and handover as reliability controls. We will learn how to structure communication around risk, set clear night shift authority, and ensure that those temporary 2 a.m. workarounds don't disappear into the shadows, but are integrated into your daytime governance. Our first step is to see the risk clearly. We need to identify the systemic conditions that quietly transform routine maintenance tasks into major enterprise risks when the sun goes down. To solve a problem, we must first speak the same language. We define handover as a shared understanding, not just a document exchange. We must respect the circadian low, that biological window where performance naturally dips, and recognize that a degraded state isn't just broken equipment. It's any operation running with temporary workarounds. The cost of a night shift failure is much higher than a maintenance invoice. It hits your safety record, your capacity, and your reputation. When fatigue sets in, diagnostic fixation happens. Teams get stuck on one theory while missing the real problem. Without proper support, nighttime maintenance often lacks the independent verification needed for high-quality outcomes. Failure is rarely a single bad act. It's a chain. It starts with an incomplete state transfer, meets a fatigued crew, hits a wall of thin technical support, and results in a local workaround. Continuity fails when information, authority, and human capacity don't arrive on the same shift at the same time. There are always warning signs. Look for acknowledged alarms that are never diagnosed, or verbal-only repairs that never make it into the system. If you hear people blaming the night crew for an event, that's a red flag that your support system, not the people, is failing to provide continuity. I want you to challenge your own facility with these 8 questions. Don't answer with what you intend to happen, but with what you can prove. For example, is there protected time for supervisors to talk, or are they just passing each other in the parking lot? If you can't answer yes with evidence, the system isn't real. Now that we see the risks, let's move to section 2, building a disciplined operating model. We need a system that makes the right action the easiest action to take under pressure. We guide this model with 5 principles. We transfer state, the hard facts, rather than just stories. We treat handover as a two-way conversation. We design for the reality of human biology, ensure authority follows the risk, and most importantly, we close the loop every morning so nothing stays temporary for long. This is the Night 6 continuity model. It's a 6-step cycle: prepare, exchange, verify, manage capacity, respond, and learn. This loop ensures that the technical standard at 2 a.m. is exactly the same as it is at 2 p.m. Step 1 is preparation. The outgoing supervisor is accountable for creating an accurate record of the shift state before it ends. This isn't just a list of what was done, but a highlight of what is currently degraded and what decisions need to be made next. Step 2 is the exchange. This is a protected, two-way brief where both supervisors review critical trends and ask questions. The goal here isn't just to hand over keys. It's to reach a shared situational understanding. Step 3 is verification. The incoming team doesn't just take the word of the log. They walk down high-risk areas and check temporary controls. They are establishing a verified baseline for their shift to ensure there are no surprises waiting in the field. Step 4 is managing capacity. We must assess the team's actual fitness for duty. If the crew is fatigued, we reallocate non-critical work and schedule extra breaks. If someone is unfit for a high-risk task, we escalate the concern as a safety risk, not a disciplinary issue. Step 5 is the response. When things go wrong at night, teams should use predefined diagnostic guides and call for qualified support. We record every decision and temporary action so the day shift doesn't have to play detective when they arrive. The final step is learning. Every morning, the leadership team must review overnight deviations. They turn those temporary band-aids into planned corrective work and assess whether fatigue or system gaps contributed to any issues. Clear decision rules prevent convenience from becoming your unofficial policy. For example, if critical info is uncertain at handover, you hold the transfer until it's verified. If a task is invasive and unplanned, you stabilize the plant instead of taking the risk. These rules provide the team with permission to be safe. A model is just a theory until it's executed. In Section 3, we look at how to translate these principles into field workflows, data capture, and management rhythms. Reliability fails in the gaps between functions. We need to name the accountabilities clearly. The outgoing supervisor provides the state, the incoming one challenges it, and the plant leadership provides the staffing and fatigue limits that make it all possible. Standard work is what makes intent repeatable. By following this sequence from preparation to sustainment, we ensure that every shift change follows a controlled, high-quality process regardless of who is on duty. Controls must be specific and observable. A procedure is not a control. A degraded state board that visually shows every bypass and temporary fix across the entire plant is a control. These are the tools that make the invisible visible. Data should change decisions, not just fill folders. We need to capture the minimum viable data: asset state, abnormal indications, work status, and the why behind any temporary controls. This creates a durable history that survives the night. We need to measure things that trigger action. Instead of just looking at production tonnage, look at handover completeness or temporary control age. If you see shift repeat events, the same alarm occurring shift after shift, that's a clear signal of learning loss. Culture becomes durable through management cadence. From the frontline review every shift to the annual strategy reset. This rhythm ensures that exceptions are escalated and standards are verified in the field, not just in an office. Technology should reinforce the discipline you've already defined. Electronic logs, alarm analytics, and fatigue scheduling tools should all point to one single version of the truth, accessible to both the control room and the on-call engineer at home. In our final section, we discuss how to apply, verify, and sustain this method. Don't try to change the whole plan at once. Scale only after you have evidence that the system works. Let's look at a case study. A pump has a vibration alarm, the standby wasn't tested, and the night crew is short-staffed. In many plants, they just keep it running. But the real decision is, what information must survive the handover to keep this situation from escalating into a total failure? By applying the Night 6 framework here, we change the system. We create an explicit record of the degraded pump, verify the standby readiness in the field, and use defined stop criteria. We treat the symptom, but we fix the system that allows the symptom to be managed safely. Success is visible in behaviors. You'll know you're winning when the incoming shift knows the exact equipment state, when temporary fixes have owners and expiry dates, and when escalation happens before limits are exceeded. These are the indicators of a resilient plant. I encourage you to run tabletop exercises like this one. Put your teams in a high-pressure scenario, like a critical alarm during a delayed shift change, and see if they know who has command and how to get qualified support. It's better to find the gaps in a conference room than at 2 a.m. Beware of the implementation traps. Don't let handover become just a signature in a logbook. Don't give generic "be careful" advice about fatigue. If you find yourself blaming a shift for an error, stop and analyze the information and support design instead. Here is a 90-day roadmap. Spend the first month just observing and baselining. In the second month, pilot the structured handover in one high-risk area. By day 90, you should be auditing the results and scaling a site-wide continuity standard. To get management buy-in, speak the language of value. The cost of protected overlap and better logs is far outweighed by the value of avoided errors, fewer workarounds, and stronger 24/7 production resilience. Reliability is a value generator, not just a cost center. To keep the system honest, use this 12-point field audit. Score only what you can actually observe. If the degraded state board isn't visible or the fatigue triggers aren't being used, the system is failing, no matter what the policy says. As you head back to your plants, remember these 3 commitments. No signature-only handovers, no fatigue signals without action, and no temporary fixes without morning ownership. Transfer the state, not just the story. For those who want to dive deeper, I've compiled several resources from the HSE and NIOSH. These cover everything from shift work communication to fatigue risk management standards across different industries. The images used in this presentation are credited to their respective photographers through Wikimedia Commons. These real-world industrial scenes remind us of the complex environments our teams navigate every night. I'll leave you with one question. What does your night shift need before the alarm goes off? Don't wait for a crisis to find out. Engineer your continuity now. Make the risk visible and make the standard executable. Thank you.